Let's get started, everybody. So, 8F.1. And again, as we've been doing with term 3, we're just going to continue to cruise through chapter 8. So like you'd think historically, 8F1 is a short exercise, it's like 5 questions. So you'd be like, oh, we'll probably do 2 exercises today. No, we're just going to do 1 exercise, and then we'll do 8F2 on Friday, another short exercise. And the idea is we're sort of a bit of time for textbook work, a bit of time for folio. So we've got class time dedicated to that task. This is a skill we've covered in Year 11, so it's just an opportunity to recap it today. And this will allow you to answer the worksheet that I gave you yesterday. You'll be able to answer all the parts of it now. And let's get straight into it. We have X is some normal distribution with a mean of 30 and a standard deviation of 5. I think historically, like if I think back to our last lesson we spoke about, that's this mean length of a fish in the river, and that's the standard deviation. Okay, mean and standard deviation is always stated as square. Now what we're doing is we're saying, what's this number k such that the probability of being larger than k is 0.23. So it really helps us to visualize that. If this is the distribution, it has a mean of 30. And we know 50% of the data lies above the mean, 50% below. And so we're saying there's some number here, k, such that the area above it, the probability above it, is 0.23. Okay, so we're going to determine that value of k. Now the operation that we use is an inverse normal calculation. So I'll take you through those calculated steps. Get the calculator out. In statistics mode, distribution, normal, inverse normal. Menu, stat, this, norm, inverse normal. Now it's going to present us with a number of options. I'll talk about what each of those represents. Okay, the first one says data. We need that set to variable, and we're going to always leave that set to variable. And we have our tail, our area, our standard deviation, and our mean. Okay, so always have the first one set to variable. Now, tail, okay, the best way to answer tail, we've got 3 options. We've got left, right, or central. Whichever way the arrow is pointing. Okay, the arrow is pointing to the right, so that means our tail is going to be right. Just quickly as well, I had this question pop up yesterday from a student. There's no significant difference for chapter 8 and 9. There's no difference between greater than and greater than or equal to, because we're talking about continuous variables. It matters in chapter 7, it doesn't matter now. So both of those mean the exact same thing. Okay, so we input all this stuff here. Our area is 0.23, the standard deviation is 5, and the mean is 30. And so if we put all of that syntax in, it's going to tell us what the value of k is that makes this true. So we've got 0.23, there we go. I've got k is 33.69, 33.7. Okay, so in the context of the fish, the probability of a fish being larger than 33.7 centimetres is 0.23. Okay, that's the probability of it occurring. That's the value of k for which the probability of x being larger than k is 0.23. Okay, next example. If it helps, draw these diagrams. Okay, the probability of x being less than k is 0.65. So that means I know here is 50%. So 0.65 is going to be here somewhere, and we're talking about this region. Okay, we're talking about the probability of x being less than k. That is 0.65. Okay, this time our tail is left, area is 0.65, standard deviation and mean remain the same. Left 0.65, 31.92. Okay, so now the probability of a fish being smaller than 31.9 centimetres is 0.65. That's what this one means. Okay, C says find the probability that the mean take away k is less than x is less than the mean plus k is equal to 0.8. Okay, so here's the mean, and then what we have is we have the mean plus k, some value of k, we don't know what it is. We have the mean take k, and we have this area is equal to 80%. Okay, so this time we're going to set our tail as central. So calculation C, tail is central, area is 0.8, standard deviation and mean remain the same. And we're going to get two values here. So I'll talk about what both of those mean. Standard deviation 5, mean of 30. Okay, I've got 23 points, so I've got x1, I've got 23.59, and x2, I've got 36.40. 40. Okay, so if I'm going to three figures, let's round them both to three figures. 23.6 and 36.4. Okay. Now, what we've done so far is like 2 out of 3 marks. We've got something else that we need to do. We're asked to determine the value of k. Okay? We have the mean plus k. The mean is 30. And so 30 plus k is going to give us the upper value. 30 take away k is going to give us the lower value. And so we can extract from this our k value is 6.4. 30 plus 6.4 will give us 36.4. Okay? All right. Okay, so the next one, like most of those skills I think we've covered in year 11, maybe not C, but this question we definitely haven't had a look at before. So this is where we start to take it a little bit further. So we've got, given that x is normally distributed, we have a mean of 50 and a standard deviation of 10. Okay, find A such that the probability of 42 being less than x being less than A is 0.34. So let's sketch what this means. There's some distribution, has a mean of 50. All right, so 50 is going to be like here. We have 42. Okay, so from 42 to some value of A. We don't really know where it is. I can deduce that it is on this side, but that's not really relevant to our diagram. Okay, but between 42 and A, the probability of this event is 0.34. Now we need to determine the value of A. So the way that we're going to do this is in 2 parts. This is a 2-part calculation. First, we're going to identify this area here. Okay, let's do that first. So our first question is, okay, well, what's the probability of our variable being less than 42? This is an NCD calculation. This was what we've covered in chapter 8 and chapter 9. This is just a basic normal distribution calculation. Our lower boundary is minus infinity. Our upper boundary is positive 42. Our standard deviation is 10 and our mean is 50. So you can type it in your run map, you can type it in your stats mode, it doesn't matter. Alright, so typing that in, minus infinity, positive 42, 10 and 50, 0.218, 0.212. Okay, so now we've got one more thing to do. We know this black area is 0.34. We know this red area is 0.212, which means the probability of x being less than A, okay, being smaller than A, we're going x being less than A, it's going to be the sum of both of these parts. So that's 0.212 plus 0.34. So what do we have? 0.552. Okay, so now what this means is we've reduced it from a sort of a 2-part problem to just now there's one calculation left for us to perform because we have A here and we know the probability of being less than A is 0.552. So now it's just our normal inverse calculation. So we go into inverse normal. Our tail is pointing to the left. Okay, we've shaded that region to the left. Our arrow is pointing left. The area is the sum of the parts that we've calculated. 0.552. Yep, 0.5. Yep. 0.552. Standard deviation and mean remain the same. Okay, so we'll evaluate that, and that's going to tell us the value. Left. 0.552. 51.307. Okay, so what this means is the probability of this distribution being between 42 and 51.3 is 0.34. Very good. Okay, that's enough for us to rip into 8F.1. So let's do it. Any questions?